So at time t equals 3, is Chloe's speed increasing or decreasing? Well, this is one of those little talked about pieces that you need to know. Speed is really particular. All right, so keep in mind that speed is the absolute value of velocity. So to know if speed is increasing or decreasing, we actually have to talk about both velocity and acceleration. Both velocity and acceleration must have the same signs for speed to increase. Okay, both velocity and acceleration must have the same signs for speed to increase. If they have different signs, then they're working against one another. Velocity tells you a direction in which the object is moving. So if you've got objects moving in a leftwards direction, that's a negative velocity, but your acceleration is positive. So that means that you're actually moving back. It's kind of pushing that against the leftward direction. So you need both velocity and acceleration to have the same sign, either both be negative and increasing in the negative direction, or both be positive and increasing in the positive direction for speed overall to increase. As soon as you've got two different signs, your speed is decreasing. So to answer part B, is Chloe's speed increasing or decreasing? We need to look at Chloe's velocity at 3. And we need to look at Chloe's acceleration. Gosh, I keep writing T instead of 3 at 3. So Chloe's velocity at 3, we need to use the correct part of Chloe's velocity, which is going to be 12 minus 3t minus t squared, because that's the piecewise function from 2 to 4, and 3 is between 2 and 4, so we have to use that part. So we plug in 3, and we get 12 minus 9 minus 9. 12 minus 9 minus 9 is what? 12 minus 18, so negative 6. Okay, step 1, velocity is negative. Step 2, what's the acceleration? Well, the acceleration is the derivative of the velocity. So we need to go ahead and derive Chloe's velocity, which is going to get me negative 3 minus 2t. And then we can plug in 3. Negative 3 minus 2 times 3. And we get negative 3 minus 6, or negative 9. So because both Chloe's velocity and acceleration are negative, Chloe's speed is increasing because both v of 3 and a of 3 are negative. The reason I put that is because it says give a reason for your answer. So let's look at this. We must, for the 2 points given in this problem, we got to have an answer here. But it's not just to say increasing or decreasing. If you say just increasing or decreasing, you don't get any points at all. You have to have a reason. So it is increasing with reason. Okay, correct reason as well. 1 point over here for your answer with reason. And then your second point comes from the work showing somehow that both acceleration and velocity are negative. So this is where work comes into play. The work, 1 point. The reason and answer, your second point. All right, so that's part B. I'm going to actually include part C in here. We're going to do 2 parts at the same time. And part C is now switching over to Brandon. So is there a time t between 0 and 4 at which Brandon's acceleration is equal to 2.5 miles per hour per hour? Well, I don't know. Let's see. Let's keep in mind a couple of things here. Brandon's acceleration is the derivative of Brandon's velocity. All right, do we have any information about Brandon's velocity? Yes, we do. We have a chart of data of Brandon's velocity right here. So we can't just find a derivative. Instead, what we're going to have to do is we're going to have to check some good old-fashioned average rates of change. So if we can find a point, or sorry, 2 points in time between which there's a slope or a rate of change that is 2.5, then we can declare that, hey, based on this chart, we found 2 points where the slope is 2.5. Therefore, between those 2 points, Brandon must have an acceleration of 2.5. Well, this is called the good old-fashioned mean value theorem. So to use the mean value theorem, we got to clear some stipulations first. Since Brandon velocity is, and let's just make sure, differentiable, yay. Okay, since Brandon's velocity is differentiable and therefore continuous, two big important keywords, over, and so I'm just going to start with 0 to 4, because if you can just, check the whole thing, maybe that's enough. Now I might have to change this, so that's why I'm using pencil right now. Since Brandon's velocity is differentiable and therefore continuous over 0 to 4, there is a time at which A of C equals 2.540 to C to 4 since, and then that since is my alert word to start showing some work. So here's what I'm going to do. V of 4 minus V of 0. I'm trying the boundaries that I start with. 4 minus 0. Let's plug this in. V of 4 is 11. V of 0 is 1. 4 minus 0 is 4. And 10 divided by 4 is less 2.5. So by the mean value theorem, since Brandon's velocity is differentiable and therefore continuous over 0 to 4, there is a time at which A of C equals 2.5 for C between 0 and 4, calling in the correct boundaries. Since using the same boundaries, the velocity from 0 to 4 is the average rate of change equals 2.5. All right, let's see how I do to the points. Well, if I look at the points, I have 2 points for this problem. First point is this alone. This alone is worth the 1 point. The work here that you've shown, 1 point, stating it correctly. Now, technically, they use the letter B. That's okay. I use the letter V. It's understood. Next, answer with justification. Velocity is differentiable and therefore continuous. Yes, there is a time. So basically, yes, this does equal it, and I've shown the work. So all of this is the justification, and there's the second point for part C. All right, I'll stop here and I'll do the last part in the final video.